everyone. Welcome to our today's meetup with Pepe today as speaker. First of all, thanks as usual. Thanks to our sponsors, Source Labs, TUI Amusement, and Trendig for supporting us and hosting this meetup. And also big thank you to you, Aurelien, my co-organizer for this meetup, and always for supporting me and supporting each other. Before we start, first the hint, if you missed the past events, you can visit our webpage continuoustestingmeetup.com. There you will find the links to our previous meetups and also the recordings. And before we start with Pepe, my technique is today a little bit weird. Before we start with Pepe, what's going on here? Just a small reminder, in November, in the middle of November, the Agile Testing Days take place in Potsdam from 13th until 16th of November, with a lot of sessions, awesome speakers. Also on Tuesday, we have to celebrate our 15th birthday. So if you were not able to book your ticket now, then do it. It will be a great event. And in the previous meetups, unfortunately, there was a little mistake with the voucher for the CTM community. So I added the correct voucher code now. And if you need it, you can just make a screenshot or also contact me via our Slack channel. All right, and today, like I said, what's wrong here? I think my mouse is, sorry for that. We have Pepe with us. Pepe is a developer advocate at Grafana, and his topic today will be beyond load testing, case 6 for continuous reliability testing. So Pepe, I would hand over to you the stage, and let's start with your talk.
Okay, thank you.
Stop sharing.
Good. And I'm gonna share my screen. Okay, just a moment. Share the sound. So, thank you for the invitation. So maybe a short intro about myself. I am an engineer who joined the K6 team, I think more than 5 years ago, and I moved to a more educator maybe role, primarily because I felt that sometimes when we build product, but we don't spend enough time explaining how to use the product. So today I am more focused on the community, explaining how to use KC and how can the tool be useful to you. So the presentation of today, let me share my slides here. So the agenda is packed. I will try to go quickly. I don't know if I will make in 1 hour, but basically KC has been built as a load testing tool, and we are moving to covering other cases, explaining the reason why we build the tool. To not making boring, we are going to go through one demo with the quick picks app, some of the concept and how you can use the tool for testing distributed system, and a little last thought about continuous testing. So let's start with the basic. I don't know if people have done load testing before or not. So I wanted to give an overview from the beginning. So basically, in my mind, it's very similar to other type of testing that we do. We want to verify something. And I would say that the big difference is here the load part. So whenever we create a load test, we could define the load in terms of users. Maybe someone asks us, I want to know how much user my website handle. I'm going to be maybe looking at Google Analytics, see the normal traffic, and create a test that simulates this traffic. Other way of setting the load is in terms of throughput. A common use case, maybe we see that we have an endpoint or a service in our system that start to struggle after a load, and we want to create a test like that. So that is a simplification about load testing, but something that I often like to also to explain is there is the difference maybe with other type of testing is what we say that is the test pass or fail. So normally when we do unit testing, integration testing, other type of testing, we are going to be doing many assertions, and if one fail, my test fail. But when we run production systems, then normally we often accept errors. We see, like, for example, when we define our SLO, there is always this 90%, 95%, my error budget. And also when we look at our metrics, we tend to see in terms of percentile, like 95% of my requests need to go below this other 5% is something that it's found that to be an outlier. So when we do a load test, we are going to be also accepting this type of failure, and this is something that the tool need to consider. So in terms of K6, the testing part of the how I am going to test the functional part. Here we have a simple test. We do an API to a product. We do a login. We are going to assert that the response is okay. We sleep this what we call virtual user. And on the other part, we have the load. Here we are setting the load in terms of virtual user, 100 virtual user that they are going to be running during 2 minutes. So we separate here what we call the scenario from the load settings. And to go a little more on details, how a test run, it's good that we see like these two parts, the scenario, the load. We have seen how we could set up in terms of duration. And then here there is another concept, iterations. In terms of casing and iteration, it's just a run of the scenario function. So if we say we want a load of 200 iterations, that means that we are going to be running 200 times this scenario function. Just to put a diagram, how it looks like. So it's going to be something like that. We are going to have X number of virtual users that they are going to be running our scenario continuously until the condition does not hold true anymore. In that case, it will be after 1 minute or after we have executed 200 iterations. So that is basically a load test. So let's go to one example. Here we have Quick Pizza. On the group that I work, we love pizza. We like to discuss about pizza. So we build a very demo app. This app can run on Kubernetes with Docker. Is open also for you to use. And we have also some example for people who want to learn how to use the tool. So we see here, this is the project. We have here a basic folder with several examples that now we will see. So some documentation about how to run the project. And okay, I cannot, how do I move here? And here is the Quick Pizza running. So I have run my Docker environment. The app is very simple. Let me try now. I need to move some control. Okay, here we have Quick Pizza. We have an advanced mode, and it's gonna give us pizza recommendation. Okay, give me a pizza recommendation. Very simple. It's just a post to a Go backend, and let's see how. Let's see a very simple test. Okay, let me. Here we have the first test on the Quick Pizza project, and this is what a basic test is. So we import some module that we are going to be using. We could pass the base URL where our application is. We talked about the load before. We set the load. This is just a post to our pizza endpoint. Then we get the response. We are going to check that the response is okay, and we are going to log in console something. So now I have here the quick fix project with the example. KC is a CLI tool. I have installed in my machine, and I can run a test like that. Foundations. This is the first test that we are going to be running. My test is running, and now it's printing console the name of the pizza and the ingredient. We will see about the test results later, but here at the bottom say we have run 5 views for 5 seconds. Very basic test. Now we will go to a little more advanced cases. So let's continue. Something that also we need to consider is our system is not gonna behave the same with low traffic than with maybe not the same 50 virtual users than 5,000, for example. And this is why also we have different type of load tests depending on the traffic. One of the common people usually ask, okay, which test should we create? Commonly we recommend like, okay, the first is like an average test, the average traffic that you receive. The other is look at your system when you have a peak traffic, create the load with this type of peak traffic. Other, which is more usual than people tend to think, is a spike traffic. Maybe on the morning we got the traffic from our baseline to triple the traffic because people join suddenly our application. And then we have also here 2 other ones, which is a very long test, so test or endurance test that I want to see how my system responds when it had been used for a very long time. And the other is about finding the limits of our system and breaking test. I'm going to be increasing the load until maybe no limit, but I know that I want to break the system and to know, okay, here it is. Different type of load, different type of load tests. We could be also looking at non-functional requirement. Seeing that we could be looking in our test is the latency, how fast our website app goes. We could be looking at the availability of our production system. Maybe we are continuously pinging like an uptime monitoring tool to see if the system is up. Other concept, reliability. Normally people think up in terms of error rate, is responding my system with error, or it could be other metric that is important for your product, for the business or for the engineer. So any other metric that is important in your service. Resilient, how quickly our system go back to the normal when the system get broken, for example. Things like that we could be also checking. And scalability. Maybe we have defined some scalability policy of some component. I want to create a load test and to see how the system scales and to just to check how it performs. So let's go, before going into other topic, to another example. So we have seen about how to model the load. I wanted to show how you could do that in KC. It's as simple as here, instead of setting the view and the duration, we could define a stage. And we could be adding here as we want. Like we could say, okay, now 100, 100. We recommend not to do many crazy things, just something more or less stable. But okay, it's very common to define load using a state. It's very common also to have a file with different load options. Like for example, I may have here a file that I'm going to import in another module with my average stage. And then maybe this load is going to be reused in different tests that I have. I could have the same for a stress test. I could have the same for a spike test. And then I reuse these load options in different tests. So going back to the presentation. So how it looked like load testing or reliability testing today. We built the tool, I think 6 years ago, because we were not happy with as a developer with the existing tools. And a lot of things have changed with traditional tools. But there is like the shift left, the DevOps, Agile, for also something that we usually like to highlight is distributed system. How not everyone are building applications like that, but it's very common. Now we can build better applications, but are also more complex, and there is also more interconnected system. That is not a call to build microservice application, but it's very common that there is many components and many people involved. And it also changed the way that we could test our system. Traditionally, we may have done an end-to-end load test. We start testing from here, and we see here how to cover the different components. But now we could also be testing maybe a particular component. Maybe we want to test just the database because we have defined a policy, or we want to see when it starts to struggle. Maybe I focus just on this particular component, or another type of reliability test to maybe integration components. A common case, I may want to see my queue system that not process tasks as fast as I want. I may put many things on the queue, and I'm gonna check how it ends finishing the task and checking the final timing between the queue consumption. So different way of also testing those systems. So before going, I would like to highlight 4 principles. I talk about we build the tool because we were not happy with previous tools, and we are starting with some principles that are still live from the beginning. So one is the debate about test as code tool, testing tool, or codeless tool, and we are of course advocate to a test as code tool. The reasons are probably 2 high reasons. One is as a tester or developer, we start maybe testing a few cases, but then over time, as we progress building our product, we start adding more tests, and we find bugs, we add more tests. So our test suite is gonna grow, and it's gonna be very easy for us to reuse modules across different tests. So that is something to do with when you program your test, and also whenever you are working with other teammates. Probably very common on our organization that teams own different systems, and they need to perform, or they need to test those systems. So it's quite common to find that they have built maybe internal framework for utility or things that they like to use between the different teams. So something that you could do with a test as code tool. Other principle, we went, okay, or the principle that being an open source tool, we know that we need to build an open source tool. We need to build a business on top. That is our cloud service. And I would not speak too much about our cloud service, but basically it allows you to run tests in the cloud. We know at the beginning that a lot of people are going to be using the open source, and maybe a percent the cloud service. What we wanted from the beginning was that independent on the mode that you run KC, you don't need to change your script. So that means that maybe you are a cloud user and want to move to the open source. You don't need to change your script. The same here is another mode that is on the Kubernetes cluster. Maybe you are running on a Kubernetes cluster, but you want to debug your test in your local machine. So you should be able to move between different systems with minimal changes. The third principle is to be a performance tool. That means that we wanted that you could create a decent amount of load without need to distribute the load across different machines. So, and here, what I wanted to highlight is that even your test will be writing in JavaScript, the tool is writing in Go for gaining this performance. So, and we like to say also very early, you could reuse JavaScript library, but we are not going to be able to run library that run on Node because of this reason. So it's very common that people get confused. This is a JavaScript tool. I could run anything on the JavaScript landscape. You are not going to be able to run a library that need to use Node.js APIs. So performance, and the last principle, extensibility. So we build the product, people like the product, and people start asking for new features, like always. And they are starting to wanted to do many things, new protocol, we quickly realized that we were not going to be able to support all the different cases. And the way to move forward was to allow people to extend the tool for their different cases. So what we did was to find an architecture or to allow what we call extension, so that you could extend KC for any logic that you want. We're going to see here a few of the extensions from the community, some writing by us. You could see here on the KC docs. So there is a bunch of protocols, sometimes we call output extensions. And basically, the extensions are writing in Go. You define a Go function, and then that is going to allow that you could use the same functions from the JavaScript code. It's not very complex. I can show one example here on the report. You could see and test later. So here we have our internal module. Here we have a function, get check results, writing in Go. Another check restriction, writing in Go. We just need to register in my Go code here, and we have here a module. I have a module now that I can import on my KC test, and I am going to have this internal check restriction function available within the JavaScript code. So that is what an extension means, and this is what also has allowed us to cover new use case for KC, and also to what we call output and output extension to be able to send the results from my test to any backend that you want. So that was the fundamentals, and now let's go to some core concepts of KC with more examples. The first thing are options. So what I wanted to highlight here is that you could define the option within the code, but you could also override them by an environment variable or with a CLI flags. Let's see, for example, we have many options. I see more than 60 options. And if you go to the KC docs, you are going to see here, for example, iteration, what this option does, how you could define iteration, how you could override here also with the name of the environment variable or with the name of the CLI flag. That's it about options. The next concept are the setup and teardown function that is very common in other testing frameworks. So you could use the setup function for doing anything before your load test starts. Normally people may interact with the testing environment or may get some data that is going to be used by the view during the load test. And then we have the teardown function here. Whenever the test finishes, I may want to close some resources of my testing environment or reset my testing environment. So let's see one example here. We go to foundation folder, lifecycle. So we have here, in the same example, we are just adding new feature. So setup function, we are going to do a request to the base URL to see if it's okay. If not, I throw an exception, and then the test won't be executed. And on the teardown, okay, we could be doing whatever we want. Here, we are going to just write a log message. Let's run the example. Let's KC run foundations number 3, lifecycle. So the website was up, we check on the setup function, and now at the end, it should write this log message. Let's see about the setup and teardown. Let's see next. Okay, result. KC, we separate like the metric that the KC collect, metric that KC automatically collect, the built-in KC metric, and the metric that you could define, custom metric. We have seen the output of those metrics on the terminal before. Just Casey, whenever you write your test, for example, you may do HTTP requests. So Casey know it would be collecting the information of those requests, and then it's gonna track that information, and he, in this case, showing you at the end a summary of the results. Here, for example, see like the data received, data sent, this one HTTP rec duration with the latency, time spent blocked, the time spent connecting, and so on. So you could see more on the documentation. And then the other are the custom metrics that we could define. So custom metrics are 4 types, the same 4 types that basic metric has. And the first type of metric is a trend metric. A trend metric is just data point. We want to store data point like response times. We say this, for example, HTTP read duration is a trend metric, and then whenever it prints, it's gonna give me the statistics here, minimum, maximum, and the percentile. Other type of metric are rate. Whenever I want, it's gonna save true or false to give me a rate of success. Here we have a case, checks. That is a metric that is gonna store all the checks that we have been doing, all the assertions that we have been doing. And here, okay, 34, 100% is okay. Here, I think this one is another one. HTTP rec fail is another check rate metric. There is 2 more. A counter is gonna just count things that we add. For example, the iterations metric is a counter that counts the number of iterations. HTTP recs metric is a counter metric that stores the number of requests that we have done during the test. And the last one is gauge, that it only gives you the last value that we saved on the metric. So instead of looking at this one, we are gonna see again one example. Let's go here to metrics. So we are adding now some custom metrics, a trend metric and a counter. So you import the module, and then outside of the default function, because it's something that is going to be used by all the iteration. So we instance the metric. So we instance the counter metric. We are going to here save the number of pizza or pizza recommendation. And here on the trend metric, we are going to save the number of ingredients. In my test, now we have added those. Anytime that we got a pizza recommendation, we add to the counter. Anytime that we got a pizza recommendation, we are going to be adding the number of ingredients. Let's go again and run this test. Basic run foundations number 4. What I expect now is just on the summary of all the metrics to be listed, those new custom metrics. Here we are. So quick pizza ingredient with the different statistics and the number of pizza that we order. So it's the same number of iterations because every iteration asks for 1 pizza recommendation. Okay. Next concept are about assertions. So in case if there is 2 way of defining assertion, one is check and threshold. The difference here is that threshold can make my test fail. So with threshold, you define your pass-fail criteria or in your test, but not with checks. So people tend to ask why you have 2, and the reason is what I was discussing at the beginning. We are gonna accept a % of error. So imagine that we are gonna define 10 assertions, 10 checks in my code, and we run 1 million of iteration, a big load test, or maybe not even too big. Maybe with 1 million of assertion, because 1 assertion failed, that does not mean that my test is gonna fail. So we are gonna be accepting this more % of failure. So checks for us could be used as an informative, something that I want to know. I'm going to run a big test, but it's going to inform me. Maybe here that was 95% okay, 90–50% fail, it depending on your test logic. So we have seen an example here. It's just any condition that you want to put here. So, and we give a name, it's status 200, and threshold, we put those on the options. Let's see another example. For threshold, here we are. So, those are the threshold part. Let me zoom in. So we need to define threshold based on the metric that we are looking. So I'm going to be analyzing. We're going to query the metric to see if that's succeed or not. So here the HTTP fail metric is the error rate of HTTP request, and we say the error rate should be below 1%. HTTP rec duration is the latency, and we are telling that 95% of all the requests should be below half a second, and the 99% should be below 1 second. We could also define a threshold on our custom metric, and here we say average should be below 8, but we have this abort on fail. So that means that while I check this threshold, if the threshold is not met, then I am gonna fail my test. That is useful, for example, for a long test that I know that my system is starting to be overloaded and I don't want to continue running my test. Let's see, okay, and sorry. So on the check, I think we have already seen here, we have a check here, all our status is 200. So let's run this example. Foundations is 5, yes, number 5. So what we are going to see here is exactly this pass or fail mark exactly on the metric that we were checking. So, and then as a result here at the bottom, we have that everything was okay. If it failed, it's gonna give me an error message. It's gonna return me a non-error code so that I can integrate on my CI/CD pipelines. I think last core concepts are modeling the load. We have seen how we could model the load in terms of constant view and 100 virtual user 2 minutes. We saw before ramping. We have seen that one. We could also model the load in terms of iteration, and we could also model the load in. We talk about throughput, but basically you cannot model the load in terms of requests per second because KSIG doesn't know exactly how many requests you are going to be executing in your scenario. So then we need to do a little differently here. So KSIG doesn't know if you run 5, or maybe there is some condition, you execute one request or you don't execute another request. But KSIG, what it can do is to always run a fixed number of iterations. So what we are going to be setting is a flow of iteration. Like we see here at the bottom is, we are going to say run 100 iterations every 1 second. So now we have 100 iterations per second. If we want to achieve 100 requests per second, what we just need to be sure that every iteration run 1 request. And with that, we will get this throughput that we are expecting to set up in our test. So again, we have the constant, and we are going to be able to define as a ramping setup. And also to mention, you could mix several different scenarios in your test with different load. Here using this scenario option, here we are telling we are going to be running an scenario, browser read the news, 1 virtual user during 3 minutes, while at the same time we are going to be stressing the news API with 5,000 virtual users. So with 2, 3, 4 scenario as we want. That is useful, for example, to create more tests that are more realistic too. So There is much more concept, so on the doc, but yeah, did not have time for more. So what next? Extensibility, how I commented before, so how we are expanding to other use case. So one of the case that we wanted to cover is browser performance testing. We often focus on the usual recommendation is start optimizing the front end. So people, when they want to start optimize, they optimize the front end. But we see here that front end does not usually change once you have optimized. Every front end application run individually on each individual browser. So to get the picture when we have too many users, we also need to see what is the load that we have inserted into the backend. So we wanted to give the ability to give the full visibility about the overall performance. So we wanted to allow you could check how your browser performs at the same time that you are injecting load in your system. So this is why we also brought a browser module, and the KSIG browser module is still an experimental module. That means that it has not fully merged into the core, but it go into the transition. And about this module, so it mimicking, so we are copying the Playwright API. For those who have Playwrighted can easily be importing this code into KSIG. We are not covering all the Playwright API, just the one that could be useful for performance testing. And by default, KSIG is going to be collecting Web Vitals metric. So let's see one example. So here we go to the browser folder. Here, a basic test. So we import the browser module, same base URL. We need to set that we are going to be using Chromium. And here we are, new page, we go to the page. We could start using also the other KSIG API, like the check. We check the header one, we click the button, we wait, we are gonna save a screenshot, we are gonna check that we got a recommendation. So let's do the same and run this test, basic browser, basic. Here we are. So we have the status of our checks at the top. We got browser metrics. We think what was, we also got the screenshot here. Okay. So that is about the browser module. We talk about testing a particular component. Here we have a performance test of a SQL database. We have on the report an example testing a Prometheus instance. So we see here on I showed the list of different extensions. Here are a few of them for testing infrastructure component. And here we are gonna inject in the example a metric into Prometheus, and we are gonna see how it works. And go back to the examples. Let's see on the extension folder, Prometheus client. So we use a extension, remote write. We are going to define a constant arrival rate. We have the client. We set up the endpoint of our Prometheus instance. And then this is a simple test, just storing some metrics. Okay, then it gets me a response. And we check that everything is okay. So let's do the same. Let's run this example. KSIG extension 2. So, and then it fails. It failed because he said we don't know this module. So KSIG doesn't know this module. So what we are going to need to do now is to build a KSIG binary with this extension. So this is done. Let me copy one command here on my notes. And this is done with this KSIG tool. We are telling build a KSIG version with the client Prometheus extension. quickly, and hopefully, yes, it built my extension. We could see here at the bottom, Casey has now produced a new Casey binary, which may be different than the one that I have previously. So if we see, we have here now a new Casey binary. Instead of using the one on my system path, I am going to be running this one. It ran my scenario for 10 seconds. And then, okay, status was okay. Let's see the Prometheus instance over here. So that is the Prometheus running within the Quick Pizza app. And I think it was service bar. We are going to be executing and see here we are. All the metrics that we have inserted from our load test. Yeah. Okay, that is about testing a particular component. And let's continue with what was the next one? Okay, chaos engineering. That was about okay, chaos engineering. What this discipline has teach us, I would say, is like to embrace on this complex system failure. So we should expect that something is gonna break, and if we are proactive and testing with failure, it's gonna help us to build more stable system. It's gonna help us to improve our system. We are also a believer on this practice, especially with this type of application. And we wanted with the tool, we wanted to integrate well with existing tools in the market. And we also wanted to bring capabilities into cases that you could also what we call disrupt from your test. So let's see this model. We took the approach of, say here, almost any interesting experiment can be driven by affecting latency or response time. So we wanted to focus first instead of killing what other tool does, that is killing a pod, saturating your memory. We wanted to allow users to inject failure so that they could really check your error handling logic. For example, you may have implemented some retry logic. Retry because my system failed, so that you tell that it worked well. Or maybe you have implemented some fallback logic. Whenever I got 2 errors, show me something. So we wanted to allow that you could test this kind of condition easily to check that your application is managing those errors well. And this is what the disruptor model does here. This is another model. It only works right now with Kubernetes environment. And what it does, you could select either a pod or a service and inject a failure. Here, we are telling the NGIC service is going to have a delay of 100 milliseconds here. Or we could say, okay, this account API that is here, this service account, we are going to 10% of the request, they are going to return a 500 status. So that is the disruptor model. At the end, what it allowed us is to start testing on a more complex environment. So we could, here as an example, we could run a browser test that you are going to be checking what is the experience when one user read the news, for example, in our newspaper. So we're going to have a running one user reading the news, checking the experience, while the news API we talked before is stressing, is overloaded, and we are going to be disrupting maybe the account API, start to see failures, and then measuring what is the performance of this user. So we still have 5 or 10 minutes, so let's go to results. We have seen basic results. By default, it's gonna print the summary of our results on the terminal. That means just the aggregated information of the metric, but Casey collect a lot of data points. So this is a way like aggregating information, but you could see like all the data points, all the graph of all the result. So here, what you could do is to, while the test get executed, to send those metrics to any packet. I think we talked before on the extension. So here there is a few options like TimescaleDB, Prometheus, Grafana Cloud, Datadog, Amazon. You could build your own extension to send the result wherever you want, and then you could start dashboarding. Let me run one example. With that one, we are going to pick up our basic test. We are going to tell them here, send to the Prometheus, the same instance for 30 seconds. We are going to be running a little longer this test for 30 seconds, the basic test. And then it's executing, and right now it's sending all the metrics to this Prometheus instance. Let me go back to the same one that we were overloading before. Now should have received K6 metrics. Click here, and here we are. So the HTTP, so we could see like let's see the iteration total. So what was the something should fail always. So total metrics. Okay, there is probably because the test is still running. No, 2 years. No, I don't want 2 years. 2 minutes. Okay, here last 2 minutes. Here are all the requests. The metrics. So what we also have are some dashboard for this setup on Grafana, like K6 metrics sent to Prometheus. We could have a dashboard for K6 metrics sent to InfluxDB, in fact, or to TimescaleDB. In fact, there is many from the community. Let's see here, we have also on the quick pizza, a Grafana instance running those 2 dashboards. So let's see the one, and here are now the results. So we set up a few visualization, common one, you could build your own. You see here, latency timing, statistic, the request rate, request by URL. There was only one post to quick pizza, status of the checks here, and any other thing. This is about basic result. This is about visualizing the result of a specific test. We also recommend to think about how you are going to be comparing different tests. You are going to be running the same test frequently. So maybe there is a moment where you find something and you want to compare again, for example, your baseline test. And also we recommend that you figure it out how you are gonna think about correlating testing data with data of your system. So K6 can indicate you if there is if latency is slow, if there is some error because it's receiving this information, but doesn't know what is happening within your system. So it would be good if you figure it out how I can get from this testing data to connect with the data in my system that it could be causing the problem. And just to wrap up a little about continuous performance testing. So 2 recommendations. We have seen here many ways of testing, and it can be overwhelming. So our recommendation is start simple and iterate in the same way that you start creating your few tests, your first test, and you are going to evolve your test suite. You could be doing the same for whenever you are thinking about automating your testing. You could start selecting a few tests, and then our recommendation is to figure it out how you are going to run those tests on the different environment that you run. And maybe you could be running this test in each environment with different purpose. This is very, very common, and the flexibility of modularizing your test allow you to do that much easily. So for example, to name some case, you could be on your QA environment, just doing like a smoke test, very low load. I check the test word, the functional aspect, and then every organization here is different, and we find many different situations. But to show one example, like for example, on the pre-release environment, maybe you are testing your major release for a few days and you want to run your test several times. You want to check for regression, you want to test your SLO. And maybe on your staging environment, you are just checking some baseline performance. You run always the same test and you see if there is some change on the general performance. And then we also recommend you to test in production if you are brave or not brave, but we recommend maybe don't take too much risk, but some case, maybe synthetic testing. Okay, reuse the same test for doing some continuous testing. And then maybe when there is low traffic, I want to run a low test because I'm going to be checking the real time, the real performance in production every night or every a few nights every week with lower load. So that depends. Recommendation, select a few tests, figure it out how to run, and then also involve other things on this testing. Because at the end, if we get some wins at the beginning, we are going to see how we are going to be testing more frequently. And then the last tip are CI/CD pitfalls. So we see that sometimes we could be blind by the CI/CD tool, and there are many cases in which some performance tests are not suitable for our CI/CD process. So maybe it's a very long duration test, for example, or I need to supervise the test. So we say continuous is more about testing consistently, that you run the same test again, more like the same system, and you see if something changed. If it is not the same test or the same system because you have changed something, reset your test, change the name, you try to look for trends in your testing and frequently. And the frequency depends on what you think it should be. And the other is also assume that our stress scores are going to fail. So we got now stress score, you could check, we could do reliability checks. So it could be, okay, now I have a way to say that this release perform or reliability is everything okay. But we see over and over that it's very hard to nail down all the reliability checks that they need to be to say that the release is ready. And many things could fail. It could fail like the SLO definition, maybe it's not mature. Maybe when we translate this SLO to my stress score, could also fail, maybe even on the stress score or even in my test. So just assume that it's gonna come with failure, and it may create a false sense of security on your release process. So there is also a guide that we talk a little more about this topic on the KSIC. And I think that's all. If you want to try, there is a few resources, documentation, the demo with Pizza, we are in Slack. I'm gonna be also on the continuous testing meetup Slack. And that's all. Thank you for your time. If anyone have any question, please, I haven't seen the chat, write on the chat or feel free to reach me later in the Slack.
I will start. How many years have you been working to learn to know all these things? Because it's very wide, I think. All these things, I mean, all these capabilities. Is it? Have you worked for a long time for this company?
Yeah, I have been working on for a long time. Yeah, it's very common to change company, but I found that we have an exciting project, and I feel that we haven't finished still. And okay, I have learned many of the things because of the year that I have. Okay, I would say like documentation is easy to follow. You don't need to learn the entire spectrum. As any tool is powerful. It have a learning curve too. That depends on the person. Do I want to get into?
Thank you.
I have a question about browser testing.
Please, Nick.
Did I understand correctly with browser testing that because in the example you showed, you just had one virtual user, So if we want to test how the browser is performing under load, then are we generating load usually using the normal backend, like backend load, and then spinning up just one browser and checking the performance of one browser, or do we have 100 browsers running?
That is our recommendation. You could run maybe 100 browsers. That is going to depend on your system. So
Yes.
a browser consumes more resources, and maybe when you run more than 5 browsers on your system, things start to break. So our recommendation is, okay, run a few instances of your browser and inject load in the backend, and that should give you an experience. But there is many people. This is a very common question. So I don't know if maybe in the future we will be a cloud browser testing in which you could run 1 million of browser instance. I don't know even if people will be willing to pay what it costs to. So our recommendation as of today is, okay, you can get the overall performance just by running a few instances and injecting the load in the backend at the protocol level.
Okay, thanks.
Okay. Yeah. Well, there's one question in the chat from Arkigo. I hope I pronounced it correctly. So I just read it out. Hi, I'm new in this world of non-functional testing, especially about performance and loading testing. Is it a good practice to run the loading tests on CI/CD? How frequently is needed to run the loading tests? How can I so many questions?
Yes.
How can I report to my team my testing results every time I run my tests? For example, on CI, I can set a Slack configuration to send the reports of my UI tests every time they are executed.
Yes. Okay, I'm gonna share the link to a guide that we wrote about this topic recently. So I think it's a good practice to perform and test on the CI/CD process, but it depends on what is exactly the type of test that you are gonna be creating. So there is some test that maybe I want to run with minimal load because it's more like a small load to see if there is some change. There is also sometimes I want to run the test, but mainly to check the baseline performance. So maybe not to do for or true. There is also case in which it depends. Like maybe you have your release there for 1 day or for 1 hour, and you want to run a few tests. I would say like everything, it depends. Don't think that you are going to be running your entire performance testing suite on your CI/CD process because it's going to slow down the process entirely. So I would say like it's more about, okay, think about your release process and figure it out how it could fit a few load tests and what type of tool of load test. High load is going to depend also on your testing environment. If your testing environment as real as your production. So at the end, you are going to need to validate like the purpose of the test, the frequency that you want to, and what is the environment that you are testing. And based on that, you are going to choose the test that may fit well for the CI/CD process. Okay. The other question is, how can I report to my team my testing results every time I run my test? For example, on CI, I can set a Slack configuration to send the report of my load. Yes, yes, you can. Your CI is gonna print you the status of the test at the end. We recommend, we have seen running the test, it's gonna show some information on the terminal, but if there is a problem, that is not gonna tell you too much information. If there is a problem, we are here, you are gonna be seeing the aggregated information. What you want is the real, the time series data, this chart to see when exactly it failed, why it started to fail. So we recommend if you run on your CI/CD process, you also send the results to any backend also. And now you see that one test has failed. Maybe I am gonna see the result, the chart, all the information, not only this aggregated information that it could be maybe not enough for investigation. I don't know, Arcigo, if you have follow-up question.
Doesn't seem so. So any other questions?
Yes, thank you. Thank you for that.
Thank you.
Also, on the other hand, sorry, I was doing other things, but I was hearing the answers. I would like to know if I can contact you for after this meeting, just to discuss some things with you about loading, if it is possible.
Yes, of course. Ping me if you are in the continuous testing meetup Slack. Ping me there, and if not, or you can also join the K6 Slack app or on LinkedIn. I don't know if I share my profile, but always happy to
Okie
help.
dokie. Okie dokie. Thank you.
Thanks to you.
Some chaos testing, you showed this sort of light map with traffic going between services. Was it just a pretty picture, or does it reflect the real system? I mean, is it possible to generate such a?
What was the question about the picture?
Yes, when you talked about chaos testing and failures, you showed what looked like a map showing traffic. Yeah,
This one?
Yes, and earlier on. Is it just a pretty picture? No, this one.
Okay, yes.
Or did you generate it out of traffic? Does it reflect a real system?
No, okay, that is a system of one application that there is on the Amazon. We show this picture to reflect that our application is built of many different subsystems. So that the complexity. There is also another one like the Netflix diagram that it shows how complex it could be, like all the microservice of Netflix. I wouldn't say that all the systems are like that, but the truth and maybe more ambitious application, there is many built based on different service. What we wanted to highlight with the chaos idea is at the end, what you want is to handle the errors. Maybe here to see what is the experience when there is an error. So what we want is to facilitate generating this error. So you generate this error. You don't mind maybe this particular endpoint failed. What you want to know maybe, okay, here when this particular endpoint failed, we start receiving those type of error. So we want to facilitate for you to generate this error for whenever you are handling those on your application. You could either even implement a good error handling or just test how that my system behave when such an error happens.
Okay. And which tool did you use then to generate this diagram?
Yeah, it's the same. So that is a module here, K6 Disruptor module. It can only connect to Kubernetes service. So what you do, you connect. There is a function connect with Kubernetes service. I am skipping here. And then you say, I want this service to start failing. Let me go to the docs, because it's hard to put everything in just one slide, but okay, you are going to be able to find here JavaScript API about this project, Disruptor.
Okay. Okay, thanks. And a final question, you showed us at the beginning about custom metrics. Is it possible to remove some of the metrics from the standard output that don't appear to be that useful for our users? For example, there's connection time, waiting time. Generally, we are only interested in request duration.
No, I don't think. I think something that there is an option that is about adding more percentile. By default, those are the percentile. You could add more percentile. I think by default you could not. There is a function within K6. Let me show you. I did not go into that detail. I'm sharing my screen, right? Yes. So you go to result output. So it gives you an overview here about, okay, we have the aggregated results here. That's what we have seen before. We are all the zoom on the terminal. And you could also process this with the handle summary function. Okay, so two types of results, either aggregated or the time series data. And whenever you are aggregating, we look at end of the test, you have this custom summary function. And on the custom summary function is another hook similar to the teardown that we saw before, that here you are going to get a JSON file with all the aggregated information. You could do whatever you want. And I think maybe there you could overwrite I am not sure, but I think I have seen. You see here, you can print to STD out too. Maybe that would be the way.
Okay, thank you very much.
Welcome.
I have a last question, and I know it's a tricky one. You are not a salesman, but why would you recommend Case 6 instead of tools like Artillery, for example?
I think I like Artillery. I didn't like about Artillery. I think was like the YARN file configuration, for example. That's the thing that I don't like of Artillery. So when I thought that we built KC like 7 years ago, when even Artillery was maybe at the beginning, there was Locus, there was not too many, Gatling maybe was starting. We were like the test as code tool, and from there is also good tools. Don't say I would say like from Artillery, like the YARN file is something that I as a user don't convince me fully.
Okay, thank you.
Okay, no further questions in the chat. So now it's your last chance to ask a question to Pepe. Otherwise, I would take over the screen, Pepe. So thanks a lot for your talk and your presentation. It was a lot of information. And of course, if you have other topics in future where you think, okay, this could be also interesting for the community, then you are always invited to come back. Of course. Okay, so what's next? Our next meetup will take place at the 16th of November, and there we will have a club with the topic, let's go with parallel testing for Cypress. So yeah, what else can I say? My technique is still doing what it wants to do. I don't know what's wrong here. So thanks for joining us today. And yeah, have a really nice evening, and see you in November. Maybe on the HR testing days, we can meet in person, and if not, then at the next online meetup. Thank you all.
Thank you, everyone. Have a good evening.